In this video, we'll take a look at a set of exercises from Chapter 1 that basically have us work with Excel and to clean some data and maybe use pivot tables to summarize the data. Pivot tables are nice to achieve a quick summarization, look at the data, and so forth. Typically, you don't want to use pivot tables within Excel to present information say within an organization, say at a managerial level, or certainly external to an organization. There are other tools, reporting tools, such as like Power BI and some of the other software items that we might look at this semester that are better for actual reporting. But nonetheless, again, Excel and the pivot table option or function basically gives us a good way to kind of get a look at the data as we might have just, like I say, gone through a cleaning process to wrangle the data to get rid of extraneous observations that don't meet certain specifications. And so, again, that's what this exercise is about. And so there's part 1 here. It says, consider the 2013 rejected loan data from Lending Club titled DAA Chapter 1-2 data. And to prepare the data set for analysis, let's scrub the risk score data. So first, because our analysis requires risk scores, debt to income data, and employment length, we need to make sure each of them has valid data. So they want us to open the file in Excel. So if you go up here, this kind of the nice thing, the data file is live linked here. You can click on that and it will download, and it will attempt, I think, to open that in the online version of Excel, and I think the file will be too large for that. It says we're fetching your file. So it says couldn't open the workbook in Excel online because it exceeds the 25 megabyte file size limit. And so just hit OK there and then just download the file up here. Okay, and then you can open it. It downloads pretty quickly, I think. And once you hit open file, Excel should open automatically. Okay, there we have it. It might come up with this, come in with this message here, protected view and so forth. Just enable editing if that's the case. And then I should be able to go back to the instruction set. Let's take a look at that. Okay, we'll just close that window now, and back here in McGraw-Hill. So we took care of part A. We opened the file in Excel, and they asked us to sort the file based on risk score and remove those observations, the complete row or record that have a missing score or a score of 0 if needed. So, and I guess kind of key phrase there is if needed. It might not actually be needed in this case. So let's do a sort. You can just highlight the first cell, cell A1. Typically you can do Control-Shift-End and capture the whole data set. I've got a couple different keyboards working here, so I've got to get the right one, right combination there. Okay, so Control-Shift-End selected all of the data, and I'll just go over here to Data. Okay, so on Data, we'll just select Sort. And we want to sort by the risk score. Okay, and so you'll choose risk score, and the data may actually be already sorted in that order, but let's do a risk score. Let's sort smallest to largest, I guess. Hit OK. And it may take it a moment. There's close to 700,000 lines of data there, so it could take a moment for it to actually sort here. So we've sorted it from low to high, and I don't see any that have a risk score of 0 or have a blank risk score. They would be grouped together after the sorting operation. You can even look at the end of the data set and see that the very last one, 990. So really there isn't in the data set that comes in with the problem any need to eliminate any rows there. It's fairly easy if you had some to eliminate. You just highlight the rows, then right click and select delete. Okay, and it'll get rid of those particular rows, but don't have any rows to get rid of actually in this case. So let's go back to our problem and see what part C says. Assign each risk score to a risk score bucket similar to the chapter that has classified the sample according to this breakdown into excellent, very good, good, fair, very bad, and so forth, based on the credit score in Exhibit 1-13. Okay, and back in McGraw-Hill, have to get back to that so we can get to the E version of the textbook. Actually pull up the same problem, I think, in the online version of the textbook. Let's see, let's get back here to chapter 1, and sometimes it's quicker if you need to get to the end of chapter 1 to go to the beginning of chapter 2 and then just go backwards, so I'll do that. Now there's the labs at the end. Let me just kind of go back a few into the problems, and so we're down here, and this is really problem 9, I think, and in that they talk about Exhibit 1-13, so you can click on that and it gives you the grading scale, so to speak, for these loans in terms of credit rating, and 800 to 850 is excellent, 750 to 799 very good, and so forth. So we want to categorize the items in this file based on that, and as kind of noted, using a nested if statement. I have too many windows open here, or tabs open, but yeah, it says consider using nested if then statements to complete this. It's a pretty handy thing to be able to do. You've likely done this before, but if not, let's just go through it, and basically let's add another column over here, and let's just call this the risk category. Okay, and we want to set up a statement that will automatically assign a descriptor like excellent or very good to each record based upon what the risk score happens to be. So we'll start off here with an if, and an if statement has, you might say, 3 parameters that you put inside of a single set of parentheses. And as kind of noted here, you can see the tooltip that pops up with this. It says we've got a logical test, then a value if true, and a value if false. So kind of described here, and everything's separated by commas here. So you always start with a logical test. So our logical test will be for this first if. Let's test if the category is excellent, that is the score is 800 or greater. So I'll just click on D2 just to reference that. We want to make this dynamic. So we'll say if D2 is greater than or equal to 800, okay, this then comes the value if true. So we put in a comma, the value of true. We want to put the word excellent, okay. And the value of false, well, that's not a single value. We need to test again. If it's not 800 or greater, we need to test if it falls in one of these other categories. Get back here. So we've tested for that. If the answer to this is false, then we want to test then for a score of 750 or more. Okay. And it will apply those tests in the order, and basically it kicks out once it finds a true statement. And so we'll say here, let's put within this if statement another if statement, so hence a nested if. And let's once again test whether D2 is greater than or equal to now 750. Okay, we'll use a comma. And we want to use the descriptor very good if that is the case. So in double quotes, again, very good. Okay, so that would be the value if true. Now the value of false, well, once again, we've got multiple options here, so we need another if statement. Another nested if statement, so an if statement within the if statement within the if statement. And so you wind up with multiple levels of nesting of if statements here. But we want to again test whether this score is greater than or equal to now 700. And I believe our descriptor is good at this point. Okay, I kind of go back to our diagram here. So 700 will be good, 650 will be fair. Okay, so you kind of see the pattern that results here. So once again, you've got to go to a nested if statement, and you say, well, if D2 is greater than or equal to now 650, we will use the descriptor fair. And what happens after that? Let's go back and look at our grading scheme. We have 2 left, okay? So that's going to require one additional if statement. So let's put if D2 is greater than or equal to 600. We want to call that poor. And when you get down to where there's only one option left, you don't have to use an if statement for that. You say, well, if it's not poor, if it's not greater than or equal to 600, the only thing that's going to be left at this point would be all those that are less than 600. And for those, we will use the descriptor. I think it was simply very bad. Okay. Now what we need to do is close all of our parentheses, and you can go through and count the parentheses if you want to, or you can just simply watch as the matching parentheses, the left parentheses, kind of show up in bold as we enter a right parenthesis. So I don't know if you're able to detect that when I entered the right parenthesis. This left parenthesis kind of showed up just for an instant in bold. And if I hit a right parenthesis now, this one will kind of bold for just an instant. Okay, you might have seen that, and then the next one, and that keeps you from having to count parentheses. So of course the alternative is count how many left parentheses you have, and you have to have an equal number of right parentheses. Otherwise it's going to throw an error. So what happens in this statement again is it's first going to test this condition. If it's true, it kicks out of the if statement. It doesn't worry about anything else after that. So once it finds a true condition, it kicks out. Okay, so that's why we don't have to worry about 800 to 850, 750 to 799, that sort of thing. Is anything that's greater than or equal to 800 will trigger a true here and label it excellent, and you kick out immediately, and you don't even look at this statement here, which would also be true, okay, for one that's like 825, it would certainly be greater than or equal to 750, but since you passed the test back here, it kicks out and assigns the word excellent to it. So in this particular case, it's 390, so we're probably down here in the very bad range. So hit the descriptor there, or hit the enter key, and you've got one of these entered. Now all you have to do is copy down. The easy way is just to hover over the corner of this cell right here and just double click. And it'll take a moment to fill in 600 some odd thousand cells, okay? But it's done so with all those descriptors, and you can kind of scroll down and see where we are. You're into the poor category, and then fair, and on down the way, good. And, at the very end there, you get to excellent. Okay, so all right, so we've got those risk categories assigned now. So let's go back then to our question, and it says to run a pivot table analysis that shows the number of loans in each risk score bucket. Okay, so pivot tables again are pretty handy to kind of rough out an analysis. What I would do here is again highlight the entire data set, do a Control-Shift-End, start at cell A1, Control-Shift-End. This gave me one additional row here. I'm going to hit my Shift key and just click on that lower right hand cell that I actually want to capture. And got a lot of data, and plus I'm recording video at the same time, so it's there we go. So the Shift key will allow you to kind of adjust. So hold the Shift key down and click the actual cell that you want. And now I don't have to worry about scrolling to the top. I'm just going to go back over here to the Home menu, or actually Insert, and then Pivot Table. Okay, and I'll just click there. Brings up a pop-up, and I typically take this to a new worksheet. So I'll go ahead and do that. And it's got the table range selected, so just hit OK. Okay, so pivot tables take a little practice. You kind of have to think them through sometimes, but this one's fairly simple. All we want to do is count the number of rows or records in each of the risk categories. So I know in my table I want the list of risk categories, so basically to be the row header. So I'm going to click and drag that risk category over here down to the rows area. And again, when I'm recording video, things are a little bit sluggish. But okay, so you see I've got all my risk categories here, excellent, very good, and so forth. You could note that they come in terms of alphabetical order. Okay, they're in alphabetical order. There are ways to sort that. We'll not worry about it at this moment. But let's also just click and drag risk category down here to the sum values area. And you'll note that it says count a risk category. There are various things that you possibly could do with a field, like sum it and do other mathematical operations on it. But oftentimes you just simply want to count how many fall into a particular area, and that is that's good for this application. You can format your table a little bit if you want to, maybe comma format, that kind of thing. If you have the table itself kind of selected here, up here in I guess pivot table analyze, you'll see an option there for a pivot chart, so you can select that if you want to, and it'll bring in a little bar chart. Okay, and it's kind of like a histogram. Again, I don't really have the categories sorted from very excellent to very bad, or but anyway, they're kind of mixed up here. But you can see the relative scores in here and so forth, and that'll help answer the question that follows, I think, in this. So which group had the most observations? Well, you go back here, and clearly it would be the fair group, so you could select that. And which group had the least observations? Well, that appears to be the excellent one. Only 2,931 out of our data set showed up in that particular group. And then, is the results from the 2013 data similar to the data from 2017, 2012? And have to look back kind of in the book on that to see what the results were, but I think it probably is. Okay. All right, so we could follow up then with the second item in the practice set here. Consider the same data set, similar to the analysis done in the chapter. Let's scrub the data for the debt to income data. They said sort the file based on debt to income and remove those observations, complete row or record that have a missing score, a score of 0, or a negative score. You can pick up with the data set here that we've got, and you can do a sort on it. Recall we didn't remove any observations based on say a missing risk score, so you're really still at the original set of data. Go back to data here, and then sort. Instead of sorting on risk score, let's sort on, I think it was income level. Income, debt to income ratio there, and sort smallest to lowest, or highest, smallest to highest. And it'll take a moment to do the sort again, because it's crunching a lot of numbers here, doing a lot of comparisons, but looks like the lowest is 0.01%. All the way down to something, let's see what this would be, 2,782,000 and 782,032%. Okay, so anyway, there's none that are actually truly 0 or blank, so there's again nothing really to eliminate. If you had any items, again, just highlight the row, right click on the row, and select delete to effectively get rid of that. So assign each valid debt to income ratio into 3 buckets by classifying each debt to income ratio into high, so that's 20 or greater, medium 10 to 20, okay, and low less than 10%. Once again, they say consider using the nested if-then statements to complete this, and or sort the row and manually input. You could do that. It wouldn't take real long to do that probably, but again, with 700,000 rows, you're having to copy those cells down quite a ways. It's probably best just to use the nested if. And again, these will be debt to income ratio buckets. So let's just call these DTI buckets. Okay, debt to income buckets, DTI buckets. Okay. And we wanted to use a nested if statement. So let's say equals if. And then that debt to income ratio, if that is greater than or equal to 0.2, we were going to call that high. Okay, so we'll say high. comma. Then if it's greater than or equal to 0.1, all right, so again, they're saying between 0.1 or 10% and 20%. Actually here, notice that this says greater than 20%, so I need to go back and take the equal sign out of my first expression here, first logical test. But next, if we're greater than, let's make sure if it's got the equal sign or not. So if it's from 10%, so it would be greater than or equal to 10%, we would put that in the medium bucket. Okay, so we will again do another if statement. Within our if statement, the debt to income ratio now is greater than or equal to 0.1. We will call that median. And there's only one other category left, and so that means we don't have to use another if statement for that. We'll just say, use the appropriate descriptor here. We were going to call that low. Okay. Within our double quotes, write the word low, close that first, or the innermost set of parentheses, and then close the outermost set of parentheses, and we should be good here. We'll hit enter, and assigns the word low to that. Let's just hover over this lower right hand corner of this cell and just double click on it, and it should copy our formula down to the rows. And okay, you see down here we had high, and somewhere in here there was medium, I'm sure. Now it's a large data set, so it's yeah, somewhere in here, still in high there. Yeah, there's some mediums right there. Okay, so looks like our formula worked. And so now, again, what they want us to do, something similar to what we did in the previous problem, is just kind of do a pivot table and then answer the question. So let's highlight our data again. Maybe the easiest thing is just select cell A1, Control-Shift-N. Again, should select all of our data. Once again, it's giving me one extra row here, but I'm just going to hit my Shift key, hold that down. Kind of grayed out on me again, so I'll wait a moment here. Okay, I had it selected and then lost it. There it is. Okay, there we are. So let's now go to Insert and Pivot Table. And let's once again put this on a new page, I guess. And this time we want our DTI buckets as the rows. And you can just count DTI buckets, okay? And so this gives us the relative frequency here of the various categories we assign. Looks like high is the largest, and low is has the least frequency. Medium in the middle, as you might expect, I guess. But anyway, you can answer the questions then that follow. Which group had the most observations, which had the least. A little discussion question there after that, but then it kind of takes us on to this last set of data wrangling in problem 4. Consider the 2013 rejected loan data from Lending Club. So it says sort the file based on employment length, remove those observations that have a missing score, NA. Note that we are including the employment lengths of 0 different than the analysis in the text. And so All right, so back to the data set. We haven't eliminated any of the data rows at this point, so let's just go ahead and do a sort and on employment length. Just change this to employment length. Smallest to largest will be fine. Takes a few minutes for it to accomplish the task. Okay, so it's done that on employment length, smallest to largest, or least to greatest, I guess. And really, I don't think we have any blank items in here. Scroll through the data, but once again, I don't really think we have anything to eliminate here. So, and they even tell us in here. So if you notice our last row of data. See if I can kind of get to that. Okay, so our last row shows up on 669 or 6,690. I guess it's 669,994, but we had a header row, which means we have 669,993 rows of data, and they kind of tell us here after you do the cleaning in these steps here, B and C, which are basically the same things that we've done in the previous two problems, that there should now be 669,993 observations. So basically they gave us in these problems a set of data that already had been cleaned according to their specifications. So once again, they just want you to do a pivot table analysis, and it says run a pivot table analysis to show the number of excellent risk scores but high DTI bucket loans in each employment year bucket. Okay, so we can go back to the top of our data, and another way of selecting all the cells, you could start with cell A1, do a Control Shift and right arrow. That'll take you all the way to the last column. Then Control Shift and down arrow key, and that will take you to the last row. Okay, and so let's insert. Insert a pivot table. Again, let's go back just real quickly here. It says run a pivot table analysis to show the number of excellent risk scores but high DTI buckets in each employment year bucket. Okay, and so actually in terms of the employment years, they didn't have us summarize those in terms of buckets, I don't think. So they run up to 10, I think. So we'll just kind of go back to our pivot table. Let's go ahead and do OK. Okay, and so employment length, you put that on the row if you wanted to. You see it runs from 0 to 10. And we could also then perhaps put underneath that, then we could put the risk score. or the debt to, let's say we had the DTI buckets, and we also had the risk category. So let's put the risk category in here. Okay, you'll see that it can kind of sum that in that particular way, and then you can also put the DTI buckets in here, and gets a bit convoluted with that. So what you might do here is consider using the columns in addition to this. So we could go with the columns in the risk category. Okay, so that moves those over there, and then we've got the high, medium, and low as the DTI buckets. So what we need at this point is a count of the items that appear in each of these DTI buckets and sorted across the various risk categories. So we can count on pretty much any one of these fields. I'm just going to click on risk category and drag it down here. And you'll notice down here the grand total, this is the same as the number of records in our data set, 669,993. Okay. And so the rest of this is kind of like filtering. What we want to do is filter so that we have only the high, low, and medium, or only actually the high DTI buckets here. So if you just kind of highlight here on one of these items here, highlight here and not up here, but highlight here, you can do the drop down, and you'll see that you can deselect all and just simply select high, and that'll get you they'll get rid of the medium and low. And you can do the same thing with the column here. We want those that are very actually excellent, so we'll choose excellent, and you get the quantity by year. Okay, another thing you could do is let's go back to what we had just before. I'm going to select everything again. Okay, back to the original 669,993. Let's change the order of the row and the row categories here. So let's take the employment length down below the DTI buckets, and you'll see you have by DTI bucket, you've got 0 through 10, 0 through 10, and so forth. Okay, and now you just filter and say, and actually you want to make sure you have selected up here high or low, medium, so not down here, but select here, and then you can filter and say I'll have only the ones that pertain to the high category. And now again you can filter your results here by excellent, those that are excellent, and you've got the totals by year. Okay, it's a little cleaner result, I guess, than the previous result, but that's how we can kind of get to that summary of those that meet various conditions. It's through the filtering. Once we've got the pivot table set up. So I believe that is all on this particular exercise. Okay, a little discussion question there, but anyway, the rest of that, I just wanted to show the data analysis with the pivot table. So again, pivot tables are useful. As a data analyst, you can use pivot tables to get an initial look at the data and understand how the data is shaped, that kind of thing. You typically don't want to use Excel pivot tables for reporting, though. You've got more, you might say, elegant reporting solutions that are available, and those should be used to kind of give you a little bit more of a professional look to your analysis.